In our previous video, we were able to solve 3 questions using logarithm functions. So we solved logarithm equations. So again, we have the index form, logarithm form, the addition law, the subtraction law, the power law, law that applies for the same number, same base, log 1 of any base is equals to 0. And now we have 3 questions again to solve this. Now let's begin with number 1. You can pause the video right away and give it a try. Log of 5, or let's say log of x squared minus 9 is equals to 5, is equals to 0. Now the main principle we'll be applying here is how to convert this from the logarithm form back to the index form so that we can eliminate the log and then simplify further. So this is that x raised to the power n is equals to y, and in the same vein, log y to base x is equals to n. So if you convert this now, so we have x squared minus 9, like we have been doing, will be equals to 5 raised to the power of 0. Now anything raised to the power of 0, as we have seen in indices, if you have not watched the video, please kindly go back and watch the video. As we've seen in indices that anything raised to the power of 0, that is b raised to the power of 0, is 1. Therefore we can say that x squared minus 9 is equals to 1. So we can simplify for x now. So x squared will be 1 plus 9, x squared will be equals to 10. So now x now will be the square root of 10, and the square root of 10 will contain a plus or minus. So our answer now will be plus or minus square root of 10. And if you plug in this value into this equation using your calculator, you will have 0. Now let's solve the next question. The next question, that's question 2, says that we are given log x to base 10 plus log x plus 3 to base 10 is equals to 1, and we are asked to simplify the value of x. Solve for x. Now we can see yes, they have the same base. Yes, the same base, x plus 3, and this is addition. Okay, definitely if it is addition, we are going to apply our addition law that says log pq to base b will be equals to log p to base b plus log q to base b. Now we'll be going backwards so that we have an entire entity for this. So when we simplify this now, we are going to have log x multiplied by x plus 3, okay, to base 10 will be equal to 1. P q to the base of 10. Okay, let's go over again. P q to the base of 10. Now simplifying this further, we have log to base 10 of x squared plus 3x is equals to 1. Now to simplify this, now we are going to convert this logarithm form to index form, and the principle behind this says x raised to the power n is equals to y, and in the logarithm form we have log y to base x is equals to n. Therefore, converting it to logarithm to index form, we're going to have x squared plus 3x is equals to 10 raised to the power of 1. Therefore x squared plus 3x is equals to 10. X squared plus 3x minus 10 is equals to 0. Now this results into solving quadratic equation. Okay, now when we solve this further, okay, using factorization method or quadratic formula as the case may be, we'll have x plus 5 into x minus 2 is equals to 0. Therefore we can say that x is equals to minus 5 or x is equals to 2. So if you plug in any of these values back into the question, we will have a resulting answer of 1. And finally, let's go to the third question now. Question 3. Question 3 is just like question 1. In the same way that we have log of x squared minus 2x plus 5 to the base of 2 is equal to 2. Now, to simplify this further, we are going to apply conversion from the index form to the logarithm form. Okay, so this is the number, okay, this is the base, this is the index. So therefore we'll just convert it and we'll say x squared minus 2x plus 5 is equals to 2 raised to the power of 2. So x squared minus 2x plus 5 is equals to 4. So let's bring 4 from the right hand side to the left hand side. So we have 5 plus 5 minus 4 equals to 0. So we have x squared minus 2x plus 1 is equals to 0. Now, if you simplify these now using factorization method or quadratic formula, you will have something like x minus 1 into x minus 1 is equals to 0. All right. So therefore, this means that we have x is equals to 1 twice. X is equals to 1 twice. So if you plug in x is equals to 1 in this case and put it back into the equation, we would have 2 as our answer. All right, should we give it a try? So let's give it a try here and put x is equals to 1. So we have log to base 2 of x squared minus 2x plus 5 is equals to 2. Okay, we are evaluating it. So instead of x, we are going to be putting 1. Instead of x, we'll be putting 1. Therefore, this implies that we have log of 1 squared is 1, 2 minus 1 is minus 2, 2 minus 2 multiplied by 1 is minus 2 plus 5, all to base 2. Now, this is going to give us 1 minus 2 plus 5 is 4. So we have log 4 to base 2. Now 4 can be written as 2 raised to the power of 2. Okay, that's log of 2 raised to the power of 2. If you apply our power law says that log of p raised to the power of n to base b is equals to n log p to base b. Therefore, this will result into, we have a base 2 here, 2 log 2 to base 2. Now, in the same vein, when we apply, remember how log of the number to the same base, okay, is equals to 1. Therefore, log 2 to base 2 is equal to 1. So we are saying that this is equals to 2 into 1, which is equals to what? 2. So equals to 2 equals to 2 confirmed. So this brings us to the end of logarithm videos. If you have any issues comprehending how we are applying indices to this, please refer to the indices series and to establish understanding in that. Once again, welcome to Joy Mathematics, a platform created to establish understanding in mathematics. Shalom.